All right, so here's a little run through on determining limiting reagent, excess reagent. So when we're given a reaction with stoichiometry, then we can just convert from one thing to another. And if we're giving two of the starting materials, then the problem is often determining the theoretical yield, identify limiting reagent, excess reagent, and so on. And so in order to do this, what you have to do are two of the stoichiometry calculations. So the limiting reagent is the reactant that produces the least amount of product, and so it's consumed completely. The excess reagent will theoretically produce more product, but it won't actually use it all because the other reagent is consumed first, and that'll leave some excess reagent behind. So therefore, the yield calculated with the excess reagent isn't the actual yield or theoretical yield. So in this example here, let's say we're making cars and we have 400 wheels and 125 steering wheels, which will run out first. So there's a couple different ways people do this. I debated on showing you another one where they could go from reactant to reactant. I find that this is the least effective for most people. Instead, go to product. All right. So you take one wheels and you figure out how many cars you can make. You take the steering wheels, figure out how many cars you can make. And we can see that with the wheels, we can make 100. With the steering wheels that we have, we can make 125. So therefore, we'll run out of wheels. And so that's the limiting reagent. It limits how much product we can form. The excess reagent will actually be left behind. We can determine how many of the steering wheels would actually be left behind. And so this yield would not be based on this number, and in fact, it would be based on this number, the limiting reagent. All right, so that's the process that we go through for this. And what it looks like in a chemistry problem is that you're going to be giving two reactants. All right, often it's not always the case, but this is the most common. And so you can be given in grams, the harder version, or you can be given in moles and so on. And so what we have to do is we have to do two stoichiometry reactions. So this is propane. So we go to one product and then we use the other one and we go to the same product and we just compare those numbers just like we did with the wheels. So in here you can convert grams to moles. All right. So that's the kind of first step in chapter 3. So doing the grams to mole conversion. So we do that for the two different ones. And then in here, what they do is then they do a second step. Most of you are actually going to combine these steps together. So you're going to do a full dimensional analysis. So you would have this part here going from grams to moles, and then you would just add on this step. I think that's much better. Why? Because what happens is you're going to have number soup. You need to keep all these kinds of units together. And notice down here, it gets even worse. We have moles of CO2, moles of CO2. So just like the wheels. And so if you have this number soup, it's so easy to get confused where's stuff coming. If you keep that dimensional analysis together, it's cleaner, neater, easier to follow and find the mistakes. All right. So with the propane, you figure out how much CO2. With the oxygen, how much CO2. And again, this is smaller. So that would be the theoretical yield. That's what we call this. And that means that the oxygen is the limiting reagent and the propane is the excess reagent. All right. I hope that helps. Let me know if you have other questions.